we're going to go over some of the part 2 questions from the January 2024 Algebra 1 Regents. So these are the open-ended questions that are worth 2 points each. And with that said, the most important advice I could give you is to never leave any open-ended questions blank. All right. So if you're here watching this video, it means that you care enough to make sure that you understand how to do these problems. That means you're probably giving a good deal of effort in class. So I feel confident that you must know enough to be able to put at least some work on paper that will get you partial credit. But we're not here for partial credit. We are here for full credit. So let's dive into each of these problems and figure out how to get full credit on them. So starting with number 25, we are given a table that has recent test scores of students, and we're asked to create a dot plot. So dot plots are very easy to make. All we're going to do is take each data point, and as I look at each one, I'm going to go ahead and put a mark next to it to indicate that I'm using it on the number line. And we're going to show that there's a student that got an 85 on their test by going to 85 on the number line. We just get rid of this little mark so it doesn't confuse us. And we're going to put a dot right on top of the 85. And this dot is going to represent that student that got an 85. So then I'm going to move on. I'm going to go to 90, and I'm going to do the same thing. But now you'll notice that there's a second data point of 90. So there's another student who got a 90. So the way we're going to do that is just literally go right on top of the dot we already drew and just draw a second dot. So now those two dots are representing two different students that got 90s on this test, okay? Now the next point is 92, and of course these tick marks are each representing 1, so 92 is right here, and I'm going to put another dot here. I'm going to go ahead and fast forward through the rest of these dots. Now we have our complete dot plot, and you do always want to do a quick check that the number of dots you have here on the dot plot is the same as the number of data values that you were given on the table. All right, so this is correct, and this would already get us 1 point on number 25, but of course we want full credit. So we're gonna go on and answer this second part of question 25, which asks us to find the median test score for the data set. So the median is the value that's in the middle of the data when it's in order from least to greatest. So if there was to be an odd number of data points, so if you look at the black dots and the blue dots that I have over on the right, these are just an example. They have nothing to do with this problem. But the black dots, there is an odd number of them. There are 7 of them. And so when I go to try to find the median, there's a clear-cut value that's in the middle that I just circled in blue, right? If there was many more numbers, and we want a quick way to find out, there were 7 dots, and I'm trying to split this in half. So I'm dividing by 2. That gives me 3.5. So that means that the median is going to be the value after the third value. It's going to be the 4th value. Okay, and that's the one that I circled. And so that's how you quickly find it. But if there are an even number of data points, like there are with the blue, I drew 6 blue dots, there isn't a clear-cut one that's in the middle. There are going to be 2 data points that are in the middle, right? And if I do the same method, just cut it in half, it's going to give me 3, except it's not just going to be the third value, it's going to be the third and 4th value in my list that I'm looking at. Now, with these 2 values, what I'm going to do, and I did not intend for that to look like a happy face, is I'm going to find their mean. And so if you don't remember what mean is, mean means that you're going to add up the values and then divide them by the number of values. So if there is an even number of data points, we take the 2 that are in the middle and we find their mean, okay? So with the data that we're given above, we had 20 test scores. So that's even. So that means that there are going to be 2 in the middle. So if there's 20 test scores divided by 2, that gives me 10, but it was even. So that means that I'm looking for my 10th and 11th values. Now, the nice thing about the dot plot is it's in order, right? It's increasing order. So going from the left, I'm just going to count out my terms. So I have the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. And then here I am at my 10th term that I'm going to highlight in the pinkish purple. So I need the 10th and I need the 11th. So the 11th is going to be one of these 90 data points. So the 2 values that were in the middle are 90 and 88, right? That other purple one is at 88. So like I said before, because there's 2 values in the middle, to find the median, we're going to add them. That gives us 178. And then we have to divide by the number of values. There were 2 values in the middle, so I'm dividing by 2. and that's going to give me 89. And so my median test score for this data set is 89. My dot plot was drawn well, and I now have a full 2 points on number 20. Number 26 is all about vocabulary. They want to know whether or not the sum of 2 radical 3 plus 6 is rational or is it irrational. So we need to know what these words mean, and we need to explain our answer. So a rational number is one that can be written as the ratio or a fraction that has 2 integers. The other way to look at it is that as a decimal, it's going to be either repeating or terminating. So when I think about numbers like 7.6, that's a terminating decimal. It's stop. Terminating means stop. 5.291, that also stopped. So that's also rational. Something like 3.7 with a bar over it, while that doesn't stop, it does repeat. And so that also was rational. On the other hand, my irrational numbers cannot be written as a ratio of 2 integers. And the way that shows up as a decimal is that it's going to be not repeating and not terminating. It's not going to do either of those things. So the most common example is pi. Everyone knows pi as a value that never stops and never repeats. And so that is what an irrational number looks like. So to figure out if the sum in question is rational or irrational, I think the easiest way to do it is go ahead and throw this in your calculator. And when you do, what you're going to get is a value like 9.464101. And you'll notice that it does not stop and it does not have a pattern. It doesn't repeat. And so because of that, we can categorize it as an irrational number. So as long as you state that it's irrational and you explain that the reason behind it is because as a decimal, it did not repeat or terminate, then you will get full credit on this question, all right? So you can fast forward to number 27 if you like, or you could stick around to hear the other explanation of knowing why it's rational or irrational. Okay, so if we look at the first term in this expression, 2 radical 3, something that we can say about the radical 3 part of that is that that is irrational. The way I know this is because 3 is not a perfect square. So because 3 is not a perfect square, that term, square root of 3, is irrational. Perfect squares are numbers like 9, 16, 25, numbers whose square roots are whole numbers. The square root of 3 is not a whole number, so 3 is not a perfect square. Therefore, the square root of 3 is irrational. So now we know that this part is irrational. The second fact, to continue this argument, is to know that an irrational number, like the square root of 3, times a non-zero rational number, like 2, okay, 2 is a rational number, and it's obviously not 0, that will always get me an irrational number. So if you multiply irrational times rational, you're gonna get irrational, as long as the rational one is not 0, okay? So that with that fact, now we know that this first term, 2 radical 3, is irrational, okay? And we're almost there. Under the last tape, we know that an irrational number added to a rational number is always gonna give me an irrational number. So an irrational number, 2 square root 3 is irrational. Added to a rational number, well, 6 is a rational number, and when I add those up, I will get an irrational number, meaning that this sum is irrational, just like we said before. It shows us a table that shows data from a recent car trip for the Burke family, and it's showing us how the hours after leaving are going to affect the miles that they are from home. And the problem wants us to state the average rate of change for the distance traveled between hours 2 and hours 4, and we have to include appropriate units in our answer. So the reason it's saying average rate of change and not just rate of change is because the car is not traveling at a constant rate, is basically what it's telling us. So they want us to find out what's happening on average between hours 2 and 4. So we're going to look at these two data points right here, where the hours are 2 hours and 4 hours. And we're going to figure out what is the rate of change in between those two. So the rate of change can be looked at in two different but same ways. It's the change in y over the change in x, or it's the formula y2 minus y1, which essentially means the change in y, over x2 minus x1. So we're going to find out how the miles from home are changing for every hour that has passed by since they left their house, okay, or wherever they left. So let's go ahead and label these ordered pairs that we have as our x1 and x2 and our y1 and our y2. And we can substitute right into this formula. So my y2 is going to be 238 minus my y1 is 112 over my x2 is 4 and my x1 is 2. Now we're going to go ahead and just subtract. 238 minus 112 is going to give me 126 over 2. And then finally, I'm going to divide, and that's going to give me 63. And so now the final piece was to make sure I'm writing appropriate units here. So the cheat sheet to figuring out how to write 63 in the context of the problem is, remember that we're talking about change in y over change in x. So change in y, let's just look back up at our table, means how many miles from home. So 63 miles. And then I like to always look at that fraction bar as my per when I'm writing it in context. So 63 miles per. And then what was our x? Our x value was the hour. So 63 miles per hour is their average rate of change. Number 28 wants us to graph this linear equation. And the first thing I need to do if I'm going to graph this is get it into y equals mx plus b form so that I can know how to graph using my b and my m. So let's go ahead and transform this equation. So I want to get the y on its own on the left side. So I'm going to start by subtracting 2x from both sides. Now, when I say that, I know some of you might be like, well, I can't subtract 15 minus 2x. You're absolutely right, and that's okay. Here's what we're going to do. Bring down the 3y. These will cancel out because 2x minus 2x is 0. 0 plus 3y is just 3y. Bring down your equal sign, and now you're right. I cannot combine these, but I can just write them on the same side together. So I can write 15 minus 2x, and that would be fine, but I am going to write it instead in the opposite order so that it's a little bit easier for you to recognize the y equals mx plus b form, okay? But had you written it the other way, it would have been fine. The y is still not by itself. It's still being multiplied by 3, so my next step is to divide by 3. So I'm going to divide the left side by 3, and I'm going to divide the entire right side. Don't forget, you have to divide both terms on the right side by 3. So on the left, I will have y by itself, and on the right side, I'm going to have negative 2/3 x plus 5. And how I got that, again, was by dividing both of the terms by 3. Now that the equation is in y equals mx plus b, it's easier to recognize there is my m, or my slope, and there is my b, or my y-intercept. So now I can use these two facts to go ahead and graph. So I'm going to graph my y-intercept first, my b, at 5 on the y-axis. So I'm going to go to 5, 1, 2, 3, 4, 5, and I'm going to put a point on 0, 5. There's my y-intercept. Now I'm going to use the slope, negative 2/3, which is my rise over run. And now because that slope is negative, I already know this line is going downwards from left to right. I'm going to go down 2. So I'm going to go down 2, and then I'm going to go right 3. So that's how I'm using my rise over run. I went down 2, right 3, and I can go again and down another 2, right another 3, and build my line. Now I can also go up 2 and then left 3, 1, 2, 3, and that'll extend my line in the other direction, okay? Because negative 2/3 is the same thing as 2 divided by negative 3. So I could go up and to the left instead of down and to the right, and that'll extend my line. Now I'm going to go ahead and connect these points. I'm going to remember to draw arrows at the end to show that it continues to go on, and my line is drawn. And then the problem also asks me to explain why negative 6, 9 is a solution to the equation. So there are two ways that we can do this. They want me to prove that this point where the x is negative 6 and the y is 9 is a solution. So we can see if it's visible on the graph. So let's go to negative 6, 9. So if I go left 1, 2, 3, 4, 5, now I'm at negative 6, and I go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I didn't draw it, but had I kept going with my slope and I went left another 3 and up another 2, do you see that I actually would have had that line, that point on my line as well? So I could say that it's a solution to the equation because it's a point that is on the line. That would prove it. Every point that's on the line is a solution of the equation. That's one way to say it. The other way to prove it is to show that the values negative 6, 9 would make my equation true. So if I take that initial equation they gave us, 3y plus 2x equals 15, well then if negative 6, 9 is on this line, then when I plug in negative 6 for x and 9 for y, I should get a true statement. So let's go ahead and make sure that happens. So 3 times 9 is 27. 2 times negative 6 is negative 12. And then 27 minus 12 is 15. And 15 equals 15. So the other way you could have proven this is to say it is a solution because it makes the equation true. So there's always an algebraic way and a graphing way when it comes to linear equations. So you can say algebraically, the point makes the equation true, or graphically, the point is on the line.